Okay, this is notes 9.1 part 2. I have to completely redo them. The last ones that I recorded turned up upside down. Anyway, last class I was getting a lot of questions about, hey, how did you come up with these equations? Well, I'm going to show you right now. This is just all I'm doing is I'm taking this compound and I'm breaking it up when I need to. Okay, I'm breaking it up when I need to. How do I know when to break it up? We're going to learn that in this next lesson. But right now, let me just show you what I was doing. Salt breaks apart in water. It dissociates. Okay, so if I'm going to break it apart, and I'm going to say this is solid, I'm going to break it apart, I have to go back and do that thing that we did with the ions. Remember when we were naming compounds and we learned ions and all that type of stuff? Well, in this case, I look and I know sodium forms a +1 ion, and I know that chlorine forms a -1 ion, which is chloride. Okay, chloride. And because it's taken place in water, I write aqueous. Okay, now how do I know that? Well, this will be given to you either in the problem or in the notes, or if you're trying to communicate that you're dissolving salt, that's how you communicate it to other chemistry, either students or your professor or other chemists. Okay, so the next one was, and salt breaks apart. The next one was an acid, and it was acetic acid, HC2H3O2. And we know this is an acid because it's got an H in front of it. And the reason we write the H in front of it is we show that when it's in water, this thing will, some of them will break apart, but some of them won't. And some of them might break apart and then come back together again. They might rejoin. And this happens trillions and trillions of times. Okay, it happens on a massive scale. But the reason we write the H in front is to show that whenever it's in water, it forms an H+ ion. Okay, so this is aqueous. And whenever it's in water, it forms this H+ ion. And on the rest of it here is this acetate anion. That's C2H3O2. And you know from your ions chart, your ions table, that acetate has a -1 charge. Okay, so that's how we show that acids break apart. Okay, weak acids will break apart like this. Strong acids will break apart like that, and we're going to get into what all that means later. So don't worry about that too much. And the last thing is sugar, C12H22O11. Now, sugar does not break apart. Okay, if this was a piece of sugar, okay, if that was some sugar, it would not break apart into carbon, hydrogen, and oxygen. It would just stay sugar molecules. This clump of sugar would dissolve and break apart, but the atoms themselves would stay chemically joined together. That's very different from what happens with salt. These individual atoms break apart. In sugar molecules, they do not. Okay, so the way we describe that, or the way we show that through a chemical equation, looks like this: C12H22O11 aqueous. We show that it dissolved the solid bit that we have dissolved, but the atoms themselves stayed joined together. Now let's go and move on to the notes. The second page of 9.1. Okay. So here's the second page, and here's what it has to say. It says, listen, the first topic, solubility. How well a solute dissolves in a solvent is its solubility. A substance that dissolves well is considered soluble, while a substance that does not dissolve well is considered insoluble. Water is a covalent compound, and it's polar. A covalent compound is polar when there is an uneven distribution of charges in a molecule, so one side is more positive and one side is more negative. This was tug of war. And tug of war, strong, weak. Okay? That's what we're talking about here. Water is a polar compound. I think that's right. Yeah. Water is a polar compound So how well solutes dissolve is determined partly by its ability to attract particles with opposite charges. Hey, you were supposed to watch that Edpuzzle video on how salts dissolve. That's what that animation addresses, okay? That animation was perfect, and it addresses how water dissolves salts. So watch it now if you haven't, please. You were supposed to do that for warm-ups today. Ionic solutes may be soluble because the positive end of water surrounds the anion, and the negative end of water surrounds the cation. The anion in this case, in this case is going to be chloride, and the positive end, positive end of water surrounds the anion, which would be chloride, and the negative end of water surrounds the cation, which in this case would be sodium. All right, I'll go ahead and put this up on the screen for you. Okay, next. A soluble salt is an ionic solute that dissociates 100% in water because they are strong electrolytes. We use a single arrow to show that the salt breaks up completely. Yeah, so a soluble salt is an ionic solid that dissociates 100% in water. Okay? Dissociates 100%. That means it breaks up 100% into its ions. An insoluble salt is an ionic solute that dissociates very little in water because they are weak electrolytes. Instead, the undissolved solid will precipitate, and we use a double arrow to show that the salt breaks up a little. Yeah, they still break up some, but not as much. Okay, they break up a little, and that's why we use a double arrow. I'll go ahead and put that on the screen right now. Okay, so we can use a solubility chart to determine whether an ionic solid is soluble. Okay, so I'm going to teach you how to do that now. Okay, example, determine whether each salt is soluble, then write the dissociation equation for each. Well, that's what I was doing before in the beginning of these notes. So calcium chloride, let's try that one. CaCl2. Now here's what you do. You take your solubility chart and you go down it on the left side here. The left side is the metals, and then the top is the non-metals. Okay, so we're going to find calcium. There's calcium right there, and then we go all the way over till we hit chloride right there. And it's got an AQ. If it's got an AQ, that means it dissolves in water. Calcium chloride dissolves in water. So CaCl2 will dissolve in water, so we use a single arrow. Okay, we look on our periodic table. We see that calcium is in column number 2, so we know it forms a +2 ion, and we know that chlorine is in column number 17, so it forms a -1. We look at the charges. Do they cancel? No, they don't. So remember, we got to put a 2 there. So there you go. That's how you do that, and we say it is soluble. Okay, and you can write that in there. Okay, let's do the next one. I'm going to write. You write them in here. I'm going to do it here on this paper. It's easier for me. Okay, so let's do the next one. Magnesium oxide, MgO. Okay, let's go back to our solubility table. Find magnesium. Now go till we find oxide right there. That's got an S. When it's got an S, that means it is insoluble. Insoluble. Okay, so when we have that situation, we got to use a double arrow. That means most of it will not dissolve. Some of it will, but most of it will not. So we use a double arrow. We say Mg, and we look on our periodic table. We see that Mg is in the second column, so it forms a +2 charge. And oxide, we know, is just oxygen with a charge, with a -2 charge. That's oxide. Mg and then O2 minus. These two charges cancel, so we can leave it alone, and we say that it is insoluble. Insoluble. Let's do the next one. Lead chloride, okay, PbCl2. PbCl2. First thing we do, go back to our solubility chart. We find lead, there it is, and chloride right there. lead chloride. That says S. That means it's insoluble. Okay, now lead's a transition metal, meaning it falls in here somewhere. I've lost where it's at. Oh, there it is. Okay, it's still a transition metal. It's below the staircase here. Anyway, so we don't know exactly what the charge on lead's going to be. So what we do is, well, first of all, we do a double arrow. We do a double arrow like so. Okay. We write out lead. We don't know what its charge is, so we can look at chloride. Okay, we can look at chloride. Chloride's got a -1 charge because it's in column 17. These guys all form, it's a halogen, they all form -1 charges. We know there's 2 of them, so now 2 times -1, that's -2, so this must be +2. Okay, so there you go, and we say it's insoluble. And lastly, the last one we have is sodium sulfate. Okay, so let's write that out. Sodium sulfate. Okay, so let's go back to our solubility chart. Find sodium, and there we go. Sodium. And now let's go and find sulfate. Sulfate's all the way over here at the very end. I don't even know if it's on the screen. There it is. Okay, sodium sulfate is aqueous. That means it is in fact, oops, let me bring it up. It is in fact soluble. Okay, so sodium sulfate. If it is soluble, we can use a single arrow. We write out sodium, and we know, right off the bat, we know that sodium, group 1 metal, forms a +1 charge. Sodium, and now sulfate, there's only one sulfate there, so SO4, oops, there's 2 of these sodiums. Okay, so that's 2 times +1, which is a +2. SO4 then must be a 2-. Or you can look on your ions list. Hopefully you didn't lose that. You shouldn't. And that's soluble. If you don't have your ions list, you might want to dig it out. Okay. I'm going to go ahead and stop this here, and I'll finish the rest of the notes in another video.